Yes, circle it in ink. If not, put an X in the problem number. Communicate you missed it. And write in the right answer so later on when you go back over this you can figure out what you did wrong. So if you missed it, put an X in the problem number and write in the correct answer so you can later figure out what you did wrong. Obviously this does not include my work, so if you didn't do this, if you have a blank piece of paper and you're just writing this stuff down, you're wasting your time. Number 2, 1/6 of 4x minus 1 to the 3 halves plus c. If you have something slightly different, let me know. Number 3, 2/7 times the sum x plus 1 to the 7 halves minus 2 times the sum x plus 1 to the 3 halves plus x plus 1 to the 1/2 or square root of x plus 1 plus c. Okay? Number 4 is e to the 2x over 2 plus c. How are we doing so far? 4 for 4? Really?
I've gone the second part of each one. So I don't know what I'm doing for the first.
Terrible. That's not good. Okay?
I didn't get that one.
Number 5, I'll look at these tonight and I guess I'll try and figure out where the common states are. Number 5, using a u of 4x plus 5, we should get 1/40th 4x plus 5 to the 10th plus c. Number 6, using a u of x squared plus 2x, you should get negative 1/4 x squared plus 2x to the negative 2nd plus c. Number 7 was rough because there were 2 negatives in there. If you let u equal 8 minus 3 theta, you'll get a negative when you find your du, but you also get a negative later when you take the derivative, antiderivative of sine u. Those 2 negatives then should cancel out and it should be a positive 1/3 cosine of 8 minus 3 theta plus c. Number 8, I slipped one in there to see if you're paying attention, but 8 is not a u sub problem. 8 is a split it up into 2 integrals problem. Put each one individually over x, then integrate. It is 1/2 x squared plus the natural log of the absolute value of x plus c. If you missed that one, right, split up, not u sub. Right? Number 9, u is x squared plus 1. Your answer then would be a couple of different possibilities. You could have 1/2, most people probably have 1/2 of natural log of the absolute value of x squared plus 1 plus c. If you did that correctly, then you would have that for answer. Just starting to talk about multiple choices, especially on the AP test. It's common that you would see 2 other possible answers. One is the possibility of no absolute value. Why no absolute value here? X squared plus 1 is always positive. So absolute value on a positive is totally worthless. So you could possibly see it without absolute value. You might also see log rules going on. If they take that half and use the log rule that says you can move that up and make it an exponent, you might see as an answer log of root x squared plus 1. Let's see, they're all fine. If you have any of those, you're good. Okay? I just want you to be aware of different answer choices. Number 10, if you let u equal sine of x, then you get log of absolute value of sine of x plus c. The absolute value does have to be there. Number 11, if you let u equal 3x plus 8, then you might have something like 1/9 of 3x plus 8 to the 13th over 13. And depending on whether you reduced or not, you might have either 8/12 3x plus 8 to the 12th, or 2/3 3x plus 8 to the 12th plus c. If you distributed the 9, that's fine too. This is not. Okay, number 12, let u equal 1 plus cosine of 4x. du then would be something like negative sine of 4x times 4. At any rate, your antiderivative is negative 1/6. 1 plus cosine of 4x to the 3 halves plus c. How we doing? Success town or failure town? Yes?
For number 10, why isn't it negative? Negative 12.
10. Did you let u equal sine?
Yeah.
Then du is cosine or negative cosine?
Would it be negative cosine?
Is what's the derivative of sine?
Oh, okay.
Yeah, it's just positive, so it should be positive. Okay?
Okay.
All right. Number 13, feel free if you have small questions, feel free to jump in. If you have more like, how do I do this, then you should come in 7th hour or wait till you get it back. Number 13, so on definite integrals, as the instructions clearly say, make sure you change the limits and don't sub back. So, first for 13, did you let u equal x plus 2? Then check your new integral. Did you change the bounds? So now it's 3 to 5 on u cubed du. Okay, on a definite integral, you change the bounds to fit u. If you anti-differentiate, that's u to the 4th over 4 from 3 to 5, and I guess I had a mistake on my key. Did you guys get 272 over 2 or 136? No? Alrighty then. So it's u to the 4th over 4 from 3 to 5. That's 5 to the 1/4 of 5 to the 4th minus 3 to the 4th. That's 1/4 of 625 minus 81. Right? 5, yeah, that seems right. 625 minus 81 is what's 544 over 2, so none of that was true. Did you get something like 270 over 4, sorry, over 4. So does that reduce? Surely it does. So did you get something like 272 over 2 or 136? So all right, number 14, let u equal x squared plus 9, so your new integral should be from 9 to 25 when you change the bounds for your u sub. Root u times du over 2. Your answer should be 98 over 3. 15, u is cosine of x. The limits are kind of kooky here, but after subbing, they are what they are. It goes from 1 to 0 of u cubed times negative du. Your answer should be 1/4, positive 1/4. Number 16, if you let, so you are supposed to, I was giving you the answer, you were supposed to show that you could tell how it comes about. So you're proving the answer is what it is. If you let u equal x squared plus 1, then you change your bounds and all that stuff. What did the bounds change to? 2 to 17? Okay. 2 to 17 of u in the denominator, 4 out front. X dx is more like du over 2. So I think this is what my new integral would look like. Something like 4 over 2 times the integral from 2 to 17 of du over u, which is 2 log of the absolute value of u from 2 to 17. That said, that gets you this step, 2 times 7 log of 17 minus log of 2, yeah? Now how do you get that final answer? Well, log rules, yeah. I mean, log of one thing minus another is the log of 17 over 2, and then the 2 can be brought up to the next one. So log rules, okay?
Yep.
All right. 17, did you get something like 2/3 f of x to the 3/2 plus c? All right. 2, my bad, sorry, 2 is, you might have been cooped out by 2 because you haven't learned one of the skills necessary to do 2, and I totally apologize. So, if you started this and said, what the heck am I doing wrong? My answer's not there. First check this. Is this what your work yielded? Do you have an integral from 1 to negative 1 of 2 minus u, root u, and a negative du? Cool. All right. Now, these guys, you can get the answer choice. This is for a later date, but we'll might as well talk about it now. If you go from 1 to negative 1, remember these are bounds here. From 1 to negative 1 horizontally, how are you changing x or u? Are you increasing it or decreasing it? You're decreasing it. So isn't that the opposite of normal dx? And so these two guys kind of cancel each other out. These mean take the opposite direction. This means take the opposite direction. So this is actually equivalent to the integral from negative 1 to 1 of 2 minus root u times normal du. Those two negatives really cancel each other out. We'll talk more about that later. You down? All right. If you have this, you're fine. Don't worry about it. Don't mark it wrong. And then your multiple choice. The answers are D, A, C. D, A, C. How'd you do? No bueno. Okay. That is due by the end of the day. If it was just a disaster or you're a total loser who didn't even do it, then get it to me by the end of the day. I also want set 51 by the end of the day. I don't know if I'll get to questions on it, but if I don't, it's still due by the end of the day. I want 51 and 51 fun sheet by the end of the day. Understood?
Yes, sir.
Cool. Okay, so notes, the lesson, optimization. This is good stuff. This is definitely one you want to use your notes on as you practice this in the next couple of days. The notes will be valuable to look back on. All right, so optimization is actually one of the biggest parts to business calculus. If you go to be a business major next year or in 2 years, they might, if you do well on the AP test, they might excuse you from it, but you might, even if so, you might look up at the business calc syllabus for your school and say, yeah, I could do that and stuff like that. You'll be way beyond what they do in business calc from this class, but there is a lot of business vocabulary in there that you should be aware of. At any rate, this will be a good intro to that. So, check this out. Optimization means just figuring out a case that makes something biggest or best or least. Depends on the problem. Each problem is a little different. It's kind of like related rates in that sense. They're all word problems. Each one's got its own different slant. You really just have to be on your game and ask really the same kind of questions. So it goes like this. Let's look at this. Okay, so you start your own business making t-shirts and selling them at open air markets. Your first day, you set the price at $15 and you sell 40 shirts that day. After manipulating the price every couple weekends, you find that for every dollar you increase the price, you sell 2 fewer t-shirts. Make a table showing price, number sold, and total revenue from sales for 10 to 25. All right, now let's assume that all other things equal. All right, in true business settings, there would be other variables like, how nice was it out? It's an open air market. What kind of spot did you get? Did you have a good spot? So those all confound the problem, make it a little more complicated. We're going to just look at the calculus. So all other things being equal, just price, number sold. So I'll get you started in this table, and then you can take it from there. You will need a calculator for some of these calculations, I'm sure, unless you're really good at mental math. So I tell you that when the price is set as $15, this is in dollars, the number you sold was 40. With that then, what's the revenue? And please notice, I didn't say profit. What's the revenue? What's revenue? Revenue is how much you take in. It's not your profit. Profit is revenue minus expenses. We're not talking expenses here. It's just how much money you take in. So you take 600. How'd you get that? Yeah, it's 15 shirts, or $15 per shirt times 40 shirts. Shirts cancel, it's $600. It says if you increase the price $1, you sell 2 fewer shirts. So that means that if you increase the price to 16, now you're going to sell 38. How much money would you collect if you set the price at $16? 608. So though you jacked up the price a little and lost 2 sales, the extra money you got per shirt paid off. Now there is surely a point where you can't just keep jacking the price up forever because nobody's going to buy it, yeah?
Yeah.
So there's got to be that sweet spot. That's the set price. That's what you're going to try and set. Would you complete the table? And we'll go over it in a minute. If you're not sure what you're doing, let me know.
Oh wait,
We're losing cash now.
Oh, boys, it's going down. The sweet spot was 17 and 18. That's actually
Are we ready?
not quite it.
Okay. So did you get a high point at 17 or 18 or
Yep,
something like
17,
that?
18 were the exact same.
6 what? 12?
12.
12. 6, 12. And then back to symmetry, 600. What's below 600?
588.
588 on both sides, and then below that, 572.
Yeah.
Okay, so there's a 16 or a power of 2 going on here. All right, cool. I get the idea. Now, let's talk about the calculus of it. It seems like 17 or 18 is the best way to go. Let's go with the calculus and what it might look like. So notice number depends on price in a linear way. Maybe I should do this, 36. I kind of said that's obvious, but the other class did not feel like that was obvious. So maybe we should take a second to, in looking at this table, when I look at these two columns and say how they relate, what in there tells me it's linear? Why is it linear? All right, exactly, there you go. Difference is always the same rate of change. If you do the same rate of change as one, and isn't that always that, or actually it's probably down because this is a negative slope, one's decreasing, but that's what's talking linear. Are you with me?
Yes.
All right, now once I decided it's linear, I now need to figure out, all right, xy is what for this problem? Now, which do you get to choose? Do you get to choose the price, or do you get to choose the number sold?
You get to choose the price.
I get to choose the price. I don't get to say, hey, it's going to sell 50. I get to choose what I'm going to put the price at. So that makes it the independent or dependent? Independent. Price is independent. I choose independent. So x, the independent variable, is?
X.
Price. So price would be the x, and the dependent variable
Is R.
the number sold. Revenue I'll get to in the second piece, but right now I'm just talking about P&N. Okay, you down? Yeah. All right. Now, think tangent line, but not really a tangent line. When we do a line, don't we need a point and a slope?
You do.
All right, the point, you should always use the given point. Use the given for your point. It's the one you can be most sure of. The one they tell you is that when the price is 15, you sell 40. Okay? Now the slope, think change in y over change in x, which for this problem means change in n over change in p. That's where they tell me that what happens when you change stuff. So what's our slope?
40 over 15.
40 over 15. That's not the change. That's one case. Negative few, so it says for every dollar increase in price, you sell two fewer shirts. So what's delta N? Two fewer,
Oh, 2, 1.
negative two over increase in price of a dollar is
1.
one or positive one, so the slope is negative two. There's a negative relationship as price goes up, so number of sold goes down. That's logical. Yeah? All right, so our equation then is instead of y minus y1 equals m times x minus x1, it'll be n minus n1 equals m times p minus p1, or n minus 40 equals negative 2
P minus 15.
p minus 15. Now often we just say, all right, call it good, but we are going to use that in a minute, so I am going to suggest this time you clean it up for use. N equals 40 minus 2p plus 30, or n is 70 minus 2p. You down?
Down.
Well, I call this a linear relationship, but it's really a ray relationship. You would only do a really kind of a segment of relationship. I mean, you wouldn't even take that all the way to the axis, because if you set price at 0, you would sell how many? 70. And that's like if you gave them away, you could sell 70. You really would just think of this as a little segment for a part of the time that makes sense, and afterwards it doesn't make sense. All right? You down?
Yep.
Now, the obvious question is, why do we do that? With this optimization thing, what are we trying to optimize? We're trying to maximize revenue, optimize revenue, max revenue. Now, that's usually the first thing you do in an optimization problem is say, what do you want to do? Trying to maximize revenue. Revenue, when we found the revenue row, which was the third row in our table, what did you do to get that 600?
Multiplied.
You multiplied it. So revenue is what times what? Formula
N times P.
N times P. Okay? Now, if I want to maximize, I want to know where R prime goes positive to negative. Because that's where the max is. Now, do I want to take a derivative with respect to time in a minute, or no? There's no time to this. I want to know how revenue changes. As I change price, how does revenue change? So there's just those two. But what's the problem with this? Calculus on 3 variables? So when I say max R prime goes positive to negative, I really mean, not yet. 3 variables. What is another relationship?
The one we just made.
Yeah. Is the one you made. Okay, so revenue equals NP can change to revenue equals P or 70P minus 2P squared, yeah? Okay, now that's good for calculus. I have from 3 variables down to 2. Now I can find the best price by finding the price at which R prime goes positive to negative. R prime, again, is not the derivative with respect to time. There's no time here. Okay, it's just as I change the price, how does the revenue change? So just those two. So what is R prime? 70 minus 4P, or 4P plus 70. What's the critical number? 70 over 4, which goes down all the way to 1735 over 2, or 17.5. When I set the price at 17.5, let's make sure that this is a maximum. So if I look at prices before that, is R prime positive or negative? If I tried something like P equals 10 in here, wouldn't this be 70 minus 40 is positive, which means revenue up to that point was increasing. Does that look like what we're getting in the table? Revenue is increasing up to the 17-ish. Okay? And then afterwards, maybe P equals 20. 70 minus 80 is negative, which means revenue starts to decrease. That also matches the table. So it decreases as we pass 17, 18. Okay, so that implies then that the best price is $17.50. Now let's make sure we answer the question. Does the question say, what is the best price? Circle it and call it good.
What is the maximum
Hey, it says, what is the maximum revenue? So the maximum revenue, when I set the price at $17.50 is,
612.
where should I put that? I get $612.50? That's the answer to the question. Make sure you answer the question. The question is often a couple different things. Answer what they ask. You with me? Try one on your own.
Math makes sense. No, I'm trying to for myself all school. You try.
Yeah. The question is, yeah, can you do it by yourself? No, that's your room. You have a test Friday, by the way. I won't be here Friday. I'm going to see my daughter, so it'll be all no calculator. I didn't want my son to do all that calculator mumbo jumbo. Yeah, all no calculator. So if you're calculator dependent, you best work that out by Friday.
I'm in good shape. More of a no calculator dependent sort of lad. Hey Cole, I'm not there yet, so it's 5/10. For every 5 cents, I decrease the Gosh, you're silly, If I got there. What do you get for it's like 100. Where is this It is negative 2. Because I did it wrong. And then I fixed it around a bunch of this. Some micro That's a lot. Honestly, this number just makes me what you are. It is the one. Oh, you're right, it is Thursday. The question is insane. $125 a next semester. And then what was? No, it's 125 cents. Oh! I better be a good candy. I'm not gonna buy that. $1.25 for a candy bar.
All right, what did you say? First of all, does anybody know what Sturgis is? One person.
Sturgis Simpson. No, that's not.
Nobody?
What did you
Does
ask?
anybody know what Sturgis is?
No. Oh yeah,
Yeah, it's the biggest bike rally in the world.
The what?
By motorcycle. All right, so anyway, doesn't matter. What'd you say for the best price? The best price is
125 cents.
125 cents. Did you get a linear equation between n and p of 500 minus 2p? Did that go up?
Yes.
Okay. Did you get a revenue equation of 500 minus 2p times p?
Yes.
Okay, tell me, pause for a second. Did you then, I assume you then went on to r prime, yeah?
Yep. Distributed.
Could you answer this question without calculus? What kind of graph is revenue as price?
A parabola.
A parabola with zeros at? 0 and 250. And does it open up or down?
Down.
So wouldn't the max have to be at the vertex, which is at
125.
125? So could you do this one without calculus? Yes, you could.
I wanted to use calculus.
But you want to find the calculus, yes. So did you get 500 minus 2p or 4p?
Yep. Yep.
And that is equal to 0 at p equal 125, and hopefully you verified that's a max. And therefore, what's the question? The price or the max revenue?
What price will maximize the revenue?
Okay, so we should set the price at $1.25 per candy bar. Okay, are you with me?
Yes.
Hey,
A question.
yes.
Is that all we have to say for like justification?
Yes, yeah, you don't have to do a first derivative justification because yeah, good question. Okay, so this is actually a lot like related rates in that every question is a little different, and that bumps students out because they're going to have to read and they can't just follow some kind of recipe. That said, there are some common thoughts that you always do for related rates, and there's always some common things you think through for optimization. All right, so now instead of like the previous one where I just broke it up into pieces for you, let's look at what a problem not broken up into pieces looks like in my thought process and your thought process. All right, so when making a can, the top and bottom need to be stronger than the sides, so the cost of the materials will differ. Now, truthfully, a can has a domed bottom, which makes things quite a bit more complicated, and the top has an opening, which makes things quite a bit more complicated. But let's assume we're talking a straight up can with no lips, no nothing, just a cylinder, right? No dome. The cost of side material is only 1 cent per square centimeter, and the cost of the top and bottom is 5 cents per square centimeter. It's a iron gauge metal. Find the dimensions that minimize cost to make a can that holds 1 liter. All right. So here's the process, okay? After reading all the words, the first thing you get is a clue. You say, what am I trying to do? I am trying to minimize cost or minimize cost. You're trying to minimize cost. That's what I'm trying to do. Find the minimum cost. All right? Now, after that, you can't minimize jack nothing unless you have an equation for that. So now you need to get an equation. So I got this can here, and the top and bottom are some type of material, and the sides are a different type of material. So what kind of can shall I make? Well, what's our, okay, a tall one. Why do you say tall one?
So then you can minimize the big cost of small.
All right, the bottom and top costs a lot, so it seems like it'll have to be pretty tall to get a low cost, but at some point, we gotta hold 1,000 cubic, so it's not like we can make like a graduated cylinder can, we gotta hold 1,000 milliliters, right? All right, so, a tall equation, so, or a tall kind of can. Surface area, is it just surface area? Okay, why not
Volume
just
as
surface?
well.
Yeah, there's volume as well, what else?
Area.
All right. So the most common thing is people say, well, obviously, if I minimize the surface area, I minimize cost, and, okay, I kind of feel what you're saying. It is about area and trying to minimize surface area, but what's wrong with this? You're trying to minimize cost, and when you look at that equation, do you see cost?
I don't see.
There's no cost there, okay, so there's no cost here. So instead, start general, okay? This is the hardest part by far for students is, how do I get the equation? I can do the calculus. If you just give me the equation, well, that's the hard part. Start here. Cost, what are the three parts to the cost? You're gonna have to find the cost of the top, the bottom,
And the size.
and the sides. Now, this is why I don't get stuck, because if I don't know what to do, I just write down something, because that at least gets you started. All right, cost top, bottom, and sides. All right, what about the top? How do I find the cost of the top?
The area of the base.
The area, now what are the units on that?
Pi r squared.
Pi r squared, centimeter squared, so is that cost?
No.
No. So what do I do with that? Multiply it by 5 cents per centimeter squared. Will that then give me cost?
Yes.
Yes, beautiful, all right? The bottom is the same, yeah? Pi r squared, centimeter squared, times 5 cents per square centimeter. Centimeter squared drop out, I get cents. Beautiful. What about the cost of the side?
That's correct.
How do you find the area of this, of the lateral surface area of the cylinder?
2 pi r times
Yeah. You unwrap it and you make a rectangle. Okay, so if you were to unwrap this side and make a rectangle, the bottom edge is the same as the circumference, 2 pi r. And the height is what it is. So the cost, you say 2 pi r times the height. Is that it? What are the units on that? Centimeters squared, but then I need to multiply that by
5 cents per centimeter squared.
1 cent per square centimeter. Okay?
Yes.
Let's do a little cleaner version without all the units. So don't you get something like 5 pi r squared plus 5 pi r squared, or 10 pi r squared plus 2 pi r h? If I dump all the units out of it?
Yep.
Okay, cool. All right, there you go. That's 3 variables I heard. 3 variables is bad.
Number 3.
What's another relationship?
Surface area?
Volume. Boom. What does it have to hold?
1,000.
1,000. Volume needs to be 1,000, and what is the volume of a can? Formula-wise. Pi r squared times height, not a third pi r squared?
No.
That's a cone. This is not a cone. All right. So, should we solve this for R or H? As opposed to related rates where they usually say you want the HDT or you want this. Feels like you can go either way. So what's easiest to work with?
I think it's probably H. I like.
In terms of R, so solve for H in terms of R. Sounds good. At least then we won't have a square root in there, yeah? Okay, so if we, oops, I just put that in itself, that's not okay. If we take that and put it into the cost equation, you get 10 pi r squared plus 2 pi r times 1,000 over pi r squared. Let's clean that up, make our life as easy as possible. What's a clean way to write this? 10 pi r squared plus
2 plus 2,000 over R.
2,000 over R, 2,000 R to the negative second. Yeah?
Wait, it's just R to the R first.
Oh, R to the negative first, right, and R dropped out. Sorry, thank you, good call. Okay? Very cool? All right, now what are we trying to do? Minimize. So we want to find where C prime goes
Negative to positive.
negative to positive here. You can see it's not always a maximum you're looking for. Sometimes you're looking for a minimum. All right, what is C prime? Am I differentiating with respect to time or just derivative of C with respect to R? How embarrassing. 20
To R.
with R. So 20 pi R,
R, dr.
no dr,
No.
minus R to the negative second. We want to know where this is 0 or undefined. For the critical numbers? What kind of algebra would you like to do to find these critical numbers?
Easy algebra.
Okay, so let's go 20 pi R minus 2,000 over R squared. I would strongly suggest you get a common denominator. So 20 pi R cubed minus 2,000 over R squared. Okay?
Hey,
So,
you can't say that.
C prime is undefined if R equals 0, but that obviously is ridiculous. Why?
We're gonna have a
You
real.
can't have a can that holds 1,000 cubic anything if the R is 0, right? So that's bogus. You could say that violates the domain. C prime is 0 if R is, just tell me, it doesn't have to be pretty or decimal.
Hold on.
Come on, just tell me what to do.
Whatever makes it 2,000.
2,000
100 over the cube root of 100 over pi.
sounds about good. If you move 2,000, divide by 20 pi and cube root. It's the cube root of 2,000 over 20 pi, which is roughly 3.169 centimeters. That's pretty thin. Okay, this is looking like a Red Bull can. All right. And then C, oh, so do we answer the question? Where are we at here?
No, we have
Okay, actually, let's verify, is this a min or a max? So just before this, say at 1, what kind of C prime would I get, a negative or a positive? If R is small, then subtracting 2,000 takes effect, and I get a negative. And if R is big, then this is bigger, it beats the 2,000, and I get a
small
positive. So did C prime go negative to positive?
Yep.
Is that a min? Yeah, now you don't have to show that, you should always investigate to make sure you found a min, not a max. All right, now we just have to answer the question. It says the dimensions that you should tell the builder do this. So I've got the radius, now what else do I need? The height. The height, where do I throw that radius to get the height?
The original equation.
Which original equation?
Like what we started with at the very beginning.
This one? Okay. So let's go 1,000 over pi r squared for the height, because that's at least solved for. And I get the height is 31.692 centimeters. Stick 31. How big? How tall is that?
It's very tall.
It's a little less than a foot.
Wow, it's about, yeah, it's right about that. That's a really long, thin can. That's cool. Okay. All right. So, at any rate, that would minimize the cost, and that's the can you would make. Okay? Actually, it's probably not the cost you would make, because then they would test market it and say, hey, do you like this can? And then they'd have to go to the 7-Eleven and say, hey, do you want to stock this can? They'd say, heck no, I can't stock that can. The shelves don't fit that can.
That's a weird can.
Okay, it is a weird can. All right, but maybe it's a distinctive. People love that. Yes? You do not have to justify. It's not a, you do not have to say because C prime went negative to positive. It's, you don't have to say the first word. Okay? That's a good question. Here we go. Let's go with, is this next? Yes. Okay. Let's go with this, an analytical geometry problem. A rectangle is inscribed in a semicircle of radius 10. Use analytical geometry, not geometry. Now,
I don't really remember.
yeah, exactly. So at that point you say, that's great. How am I supposed to use analytical geometry if I don't know what that means? Geometry would be if you said, here's a circle, and here's the radius is 10, and the rectangle is base times height, and all that's great, and that's bad, okay? Instead, analytical geometry is to throw those geometric figures on the coordinate plane so equations can be used. So if, for example, I have a radius of 10, then that means either that x squared plus y squared equals 100, or if you like, because it's only a semicircle in the top half, we could also say that's the same as y is the square root of 100 minus x squared. The positive, because it's the top half of the circle. You follow? Mm-hmm. And the rectangle, instead of base times height, we're going to say the base is, give me something x and y-ish for the base. 2x for the base, okay? X to the right, x to the left. For example, if I made a rectangle from 8 to negative 8, isn't the base 16, or 2 times that x, yeah? Mm-hmm. And the height? Y. Y. All right, cool. So we're trying to maximize the area. We have an equation, 2xy. Now what do we do?
Take the derivative.
Not yet. We have
Plug it.
Plug in the square root here.
3 variables. So we want to substitute. So yeah, what's another relationship between the area besides the area?
Oh, y equals square root of 100 minus x squared.
Yeah, area is 2x times the square root of 100 minus x squared. Now this does take calculus skill. Those parabolas and stuff, it doesn't take any skill to do a derivative on those. These take skill. So a prime, product rule with chain rule. You can see now why this had to come after set 50, because you hadn't done combined rules yet. So what is a prime, the product rule and chain? 2x first stays the same. Cool. Now let's get into derivative second.
1 half 100 minus x squared to the negative 1 half.
The negative 1 half times
Negative 2x.
negative 2x for the derivative of the inside. All right. We did first times derivative second plus
2 times.
All right. Now, we want to find the critical numbers, so we want to see this is 0 or undefined. A lot of algebra needs to be done here. We need to get a common denominator. We need to do a lot of cleanup. So I have 2x, negative 2x, and 2 root 100 minus x squared in the denominator. You see?
Yep.
And over here, we just have a normal 2 root 100 minus x squared. You want to hack out a 2?
Good morning, Devlin Network. Please rise to the Pledge of Allegiance.
Worst kind of.
Yeah, we're just getting.
Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Continue on, find the critical numbers.
Extracurricular activities after school today have been canceled, and school will be moved to Thursday.
No school.
Please sign up early for 7th hour. Passing period is only 5 minutes, and it will be too late. Veterans Day is quickly approaching. As we continue to focus on starting chain reactions to spread appreciation and compassion for others, inspired by last year's Racial Challenge Assembly, we are excited to invite American veterans with an affiliation to the Dublin community to our Veterans Day tribute event. Please invite any veterans you know to participate in our tribute at noon on November 11th. Please see the hallway flyers or the facility for more information. Do you have Jaguar experience? Do you want to be on the sidelines and get in the game for free? Do you want to help get the crowd going in our mascot, DJ? If you are interested in this incognito position, talk to Miss Natalia. applied there or are thinking about applying.
Oops.
Today is
This
your
is
chance to
nuts.
get started in here. That's a big problem. Don't forget, Brown College is typically 9 schools. Don't forget to nominate teachers for the Teacher of the Month award. Go to the Devlin homepage and click on Teacher of the Month icon found next to the Devlin press releases section. Congrats to everyone participating in the USC math competition today. Thanks to Student Voices Operations Food Fest, students can participate in a fun spirit day on October 31st. Each grade has themed costumes, 7 snacks and food, 8 sports, 9 childhood TV characters, 10 superheroes, 11 Disney, 12 teachers and teachers, 12 animals, and teachers will be monsters versus heroes. No masks, props, or blood, and make sure to keep your costumes dress code friendly to keep this fun tradition. Wahahaha! See you soon! Senior high students, this week all 9th grade will meet in reports their top play exhibition games. Today last week, 8th grade people will report with Mr. Washington House, and Elder R will report with Miss Harrison in the cafeteria. Attention guys, would you like to have you and your friends' hilarious childhood photos in the yearbook? Send us your funny or cute childhood pics, more recent or a major throwback for the opportunity to recreate them and relive your happier days. Send them to their email or DM them on the yearbook system. Dazzling Dash! Congratulations to these Devlin gymnasts for their Class 5A 4A Devco League Gymnastics All-Conference honors. Emily Lamont and Sarah Hitchcock were both awarded first team all-around.
Cool.